Welcome, folks. I'm Jaby Koay, joined by AMBRE. I don't know your last name because it's difficult to say. I'm going to say Rufio. Is it?
Close. It's close. It's Trujillo. But yeah, you're wrong.
Trujillo.
Yes.
Trujillo. We're looking at Astrophysicist answers questions from Twitter. Tech support, Wired. This is from Wired, the YouTube channel. If you guys haven't already, you can subscribe to their channel. There's a link in the description below if you want to click on that, give the original upvote. And also subscribe here, bell icon, all notifications, and vote this up to let YouTube know you're enjoying what you're watching. Follow AMBRE on Instagram, if you could be so kind. You're super into space stuff. You want to tell the audience, real quich, what you're about?
That's pretty much what it is. I'm super into space stuff. I'm a space enthusiast. I love learning. I love to ask questions, and I happen to, work in the space industry doing some media stuff for this really great nonprofit called Space Foundation. Look into them. They're incredible.
What happens when you travel faster than the speed of light? You can't. I'm Paul Sutter. I'm an astrophysicist, an author, and a host, and today I'm reading questions from Twitter. This is Astrophysics Support. At Kieran763333419, will someone please explain what is dark matter? Dark matter, a better name for dark matter is invisible matter. We've noticed through countless observations in astronomy that there simply isn't enough stuff in the universe to account for all the motions and dynamics. And so we think 80 to 90% of all the matter in the universe is simply invisible. And whoever said it had to be visible? Yeah, that's our rules, not nature's.
This has always been something that's been curious to me because they say that most of the universe is dark matter and dark energy. And I'm like, but we don't even know what that is.
Right.
And
it's kind of like a placeholder.
Yeah, it's just a parenthetical. This big scientific parenthetical because a huge grading of information in there that we just have yet to uncover.
Yeah.
Peeling open an onion, different layers and whatnot of data and information, but we just go, just a catch-all word, dark matter, dark energy.
And it's a good one.
Yeah.
It's a good one. It makes you want to go, what is it? But the reason why he says invisible matter is because we can't see it. So when you think of dark matter, you think that they're looking for something dark.
Yeah.
Right? So that's why he said invisible matter.
How many exoplanets have been confirmed to date? Please, AstroPals. Hey, I'll be your AstroPal today. So as of right now, we have confirmed around 4,000 to 5,000 exoplanets, with more coming online every single day.
And every single one of them are around dwarf stars, right?
No.
Really?
I don't think so. You know what? I actually don't know if they're around dwarf stars, but I don't know why they.
If you remind me to bring it up, if he doesn't talk about it, just remind me and I'll explain why I think that.
That sounds like a lot, but we suspect that there are around 1 trillion exoplanets in the Milky Way galaxy. And what we're hunting for is an Earth 2.0. We haven't found one yet, but we are finding all sorts of crazy planets. We're finding planets bigger than Jupiter, smaller than Mercury. We're finding planets the size of Jupiter orbiting right up against the face of their stars, where they're literally getting their faces melted off. At Daryl16519C, question for astrophysicists: do galaxies spin clockwise or counterclockwise? Yes. At Rat697219661.
That was good.
I just have one question, thank you. Why does a person in space age at a different rate than does someone on the Earth? So this has nothing to do with space and everything to do with motion and acceleration and gravity. We've learned through special relativity and general relativity that different clocks tick at different rates. So the faster you move in space, the slower you move in time. The stronger gravity you have, the slower you move through time. Clocks throughout the universe are all asynchronous and out of sync with each other.
Yep.
At NKB_Sean, wonder what it's like inside a black hole. The inside of a black hole is probably the weirdest place in the universe. Outside of a black hole, you can go in any direction you want, up or down, left or right, front or back, but you must go into your future. You are forced to travel into your own future. Inside of a black hole, you are forced to travel to the singularity, the point of infinite density in the center. No matter which direction you look, you will always head towards the singularity, and you will reach it in a finite amount of time. So have fun in there.
I don't think I'd ever want to go into a black hole.
Well, there's no getting out. As far as we know. No. Unless it just spits you out as random arbitrary matter.
Yeah. Do you know what a white hole is?
I was just about to ask you about that. Because I'm sorry if I blew your ears a little bit. I was just about to ask you about that. I got so excited because you were reading my mind. I watched this whole video talking about white holes, and at the end, the guy was like, yeah, we don't know for sure if it exists. I'm like, wait a second.
Yeah, nobody's seen it.
You just took me through this whole journey just to like tell me that you don't know if it's actually there.
Yeah.
The interesting thing was in this video, they were talking about what would happen if a white hole and a black hole collided, and the black hole would just eat it, I think, if I'm not mistaken.
Well, I have no idea what that would even look like, because there's an idea that a white hole is the other end of a black hole. So instead of, you know how no information can escape a black hole, only information can go out of a white hole. So no information can get in. It's like the opposite of a black hole.
That would just make me think that it's almost like a wormhole or something. Like when you go into a black hole, it's like teleporting somewhere else in space. I mean, I heard somewhere that like arbitrarily you'll just find stuff coming, just like showing up outside of a black hole for no reason. Clearly it came from the black hole. I don't know. This is stuff I don't understand, but I'm fascinated by it.
I mean, I'm fascinated by black holes too.
I just remember watching Interstellar.
Oh, I love Interstellar.
Matthew McConaughey is going into the black hole, and I'm like, how isn't he not dead? Shouldn't he be spaghettified or something like that? But then I realized what was going on. I'm like, oh, I see. I don't want to ruin it for you. If you guys haven't seen it, you should definitely watch Interstellar.
You should definitely watch Interstellar. You know that an actual Kip Thorne
Yes.
Theoretical.
Yeah, I bought his book.
Oh my God, it's so good. You have it?
I haven't been able to read it. Kip Thorne goes, I dumbed this down so that anyone can read this. I go, okay, cool. I'm stupid when it comes to that, so I'll have fun reading this. And I started reading it. I'm like, you did not dumb this down enough. This is very difficult and complex ideas. Like I
had it in an audiobook form, and I went, oh, this is I can't. You have to give me pictures.
What is a parallel universe? There's two senses of parallel universe that come into physics. One is through quantum mechanics, where every possible interaction can branch into multiple different possibilities, each representing a different option for that interaction. And another option where the early universe underwent a period of rapid expansion, and then different universes bubbled and nucleated off like soap bubbles in a foam. We don't know if either of them exist, by the way. At Womanbot. How old
I love
is the
parallel
universe?
universes.
These
Sometimes
are
I'll
the
just
things
like
I ponder. Hey, I ponder these
try
too.
to, like,
13.77
throw off
billion
the things.
years old, plus or minus 100 million years. At Coffee Ice Cream, can anyone explain to me what are cosmic rays before I throw these notes down a cliff? Cosmic rays are high energy particles generated in gigantic explosions throughout the universe that are constantly soaking all of space. Just don't leave the Earth and you'll be fine.
Wait.
CGR, cosmic galactic rays. They're no fun.
I don't even know what a cosmic ray is. Like I've heard of what's it called? Where like a star explodes and a gamma ray bursts.
Gamma rays, yeah.
GRBs. I've heard of those. I don't know what a cosmic ray is.
So they're just highly energetic particles. So it's a real problem that actually astronauts on the ISS have to worry about. People that are going to like create habitats on Mars. Microwaves is a different type. Well, I'm actually not exactly sure if cosmic rays are on the electromagnetic spectrum. I just know that they're highly energetic. But microwaves is a type of light. It's on the lower end of the spectrum. It's near like radio waves.
So the radioactivity that astronauts have to worry about while in space is from cosmic rays?
All rays too.
All rays. Okay.
All rays.
All right.
But yeah, so one of the things that a lot of space agencies are working on is astronaut health, because you know when you go to Mars, you're going to be traveling for a little bit, so you have to be protected from those.
Just like 2.5 years.
Yeah, just 2.5 years. And we're protected by our atmosphere, and once you leave that atmosphere, you're no longer protected by it. The worst that we get are UV rays, which is why you get a sunburn.
So you just need to give them a vat of sunscreen then.
Oh, that's it. That's all you need, NASA. Have you thought about sunscreen?
Come on.
I don't think you did.
Super easy.
What are the properties of planetary systems, and what can they tell us about how they form and evolve? We have found so many different kinds of planetary systems in the galaxy. Like you can take the craziest sci-fi author with the craziest idea, and it still comes up short to what we actually observe in the real galaxy.
Wow.
With actual planets around other stars.
Wow.
Take, for example, the TRAPPIST system, the TRAPPIST-1 system. These are 7 Earth-like planets orbiting a red dwarf star, where 3 of them are in the habitable zone of that star, meaning liquid water can potentially exist on their surface.
I didn't know about that.
So we've seen
You haven't seen the TRAPPIST?
No,
planet?
Every time I've heard about exoplanets, it's always been like one Earth-like planet.
Just because it's in the Goldilocks zone doesn't exactly mean that it's Earth-like. It has to do
in the
with
habitable zone.
Yeah, which is habitable. They call it the Goldilocks zone as well because it's not too hot, not too cold, just right.
Right. Yeah.
So Earth-like also has to do with like the mass of the planet
and
everything. It can't just be like a rocky planet or things like that in the Goldilocks zone.
And this is more of an assumption, right? Because it could be a gaseous planet that they're looking at.
Well, no, I'm one of them. They have
you just mean like collectively
instruments.
scientists.
They have scientific instruments to be able to determine what chemicals are in the rocks and in the atmosphere. It's called spectroscopy.
Okay.
And they can actually analyze the light to figure out what minerals are inside the atmosphere. It's really interesting.
Okay.
Like looking at light and being like, oh, I know what's in your atmosphere.
Right. We got to come back to that.
Yeah.
Every combination of planets out there and stars out there. We've seen planets around binary stars, around triple stars. We've seen planets around big stars, around little stars, even dead stars. We're not quite sure what this tells us about the story of planetary formation because we're still gathering that data. We're still mining that treasure. At Swaggy Shrek Simp, what is astrophysics and why do I want to do it? Astrophysics is the study of all the stuff that happens in the universe, and it's awesome. At Crypto Glitter asks, I wish I knew more about astrophysics. Hey, me too. Like, how do binary star systems even work? How does that happen? Space, question mark, exclamation point, repeated several times in a row. This is why I love astrophysics and cosmology and astronomy. We're just talking about the weirdest stuff in the universe here. Binary stars are actually the most common kind of stars in the galaxy.
I forgot about that.
Because when you form a star,
completely forgot about that.
Big cloud of gas and dust and it collapses to form a star. We found multiple star systems all over the place.
Maybe we're such lonely people because we're in a very unique solar system that has one star, one lonely star, whereas most solar systems have two stars that are paired together.
Yeah, maybe that's why. That's exactly why.
We're born of star stuff. Maybe it makes sense.
We were almost a binary star system.
Well,
we didn't just form the sun, but that same cloud of gas and dust led to the formation of
Jupiter?
the planets. And so if Jupiter were 20 times bigger,
so I was right.
Yes.
Jupiter, yeah.
It too would have been a star. And life on Earth would have been impossible.
Well, wouldn't that push the habitable zone out further if Jupiter was also a star?
Well, if Jupiter was also, the three inner planets wouldn't exist.
Right.
For one.
It would just be, I don't know. I don't know what I'm talking about. I'm just saying maybe there would be a habitable zone outside of the binary formation. That's it.
Yeah, no, it definitely could. Just like any other binary star system, there could be, Goldilocks zone.
We would just all be part of Jupiter.
When will the universe end? Not soon enough. I'm just kidding.
Trillions of years from now.
Probably gonna last forever. As far as we know, it is going to continue expanding forever. Eventually, every galaxy will be ripped away from every other galaxy, and all temperature differences will diminish until we're left with a cold, empty.
This is the kind of existential stuff that I think about all the time.
Yeah. There's a video I watched that hopefully I will remember to put a link in the description below. It basically talks about the rest of time, but the name of the video always eludes me for some odd reason. It's a 30-minute long video breaking down the different stages of the rest of time up until the end of the universe, until nothingness. Basically until the point when the universe is no longer changing because it is just a void. Because all matter has disappeared. It's a wonderful video because it makes you think about so many things while also educating you about the universe. And so it makes you realize how impossibly, stupidly, like infinitesimally insignificant we are.
Beautifully,
right?
though.
Beautifully.
Yeah, beautifully.
But it also highlights the fact that like we have right now. And so that should be appreciated. So I really want you guys to watch the video after you've watched this if you can. There's a link in the description below, hopefully, if I remember to put it there.
Is it possible? The gravity of our galaxy and what makes up our galaxy is why the speed of light from our location seems to be constant. But in other galaxies and places in the universe where things are different, the speed of light constant is different. This is a great question because we are constantly wondering if the constants of nature really are constant. And as far as we can tell, every single observation, measurement, and theory has confirmed that the speed of light really has been constant. Seriously, we've tested it. From observations from the very earliest moments of the Big Bang itself, the speed of light is simply the speed of light. And if the speed of light did change, would totally mess up physics and make our lives a lot harder. At GML Music, a casual question for astrophysicists. Hey, let's chat. How many dimensions are there?
Watch What If.
4. We know that we live in a four-dimensional...
What If is a Marvel show. It's not something you're... But Marvel... The whole thing with the Marvel Cinematic Universe is exploring multi-dimensions now. If you watch What If, there's an episode where they basically go into like this part of space that... It's fiction, right? But it's looking at all the different universes at once, and it's just fascinating to think about.
That's super cool. Wait, I didn't know this. That I'm not.
Now I'm going to turn you into a Marvel head.
Did that just happen? Have I been converted? I mean,
that's where it's all headed right now, is the multiverse. I mean, the next movie's literally called Doctor Strange and the Multiverse of Madness.
No universe. 3 of space, 1 of time, interwoven into a fabric that we call space-time. There might be more big dimensions or small dimensions, but those are all speculative theories. At Michelle Floyd, today's astrophysics question: does the spin of a galaxy influence the spin of other nearby galaxies? It must. It must not. It doesn't. They're billions of light years away. At JHatman8 says, what caused the Big Bang? It's hard to believe that a microscopic particle started the Big Bang. Another option I just thought of is a large vacuum and a large pressure collided and boom. We don't know what caused the Big Bang. We don't know what started the universe. Our models of the universe take us to the very earliest moments, but without a theory of quantum gravity, we don't know what started at all. We don't even know if that...
What?
Imagine that, like, we build, we keep building and we keep expanding, and we finally get to the one question that has eluded us for since humanity started, and it was something like a fart.
Something so juvenile.
It probably is.
I mean, I'm sure that here we are on Earth, like theorizing and trying to come up with like whatever the best of science and math can tell us, and it's probably something simple. But when you're looking at it from, I use this in a very loose kind of way. When you're looking at it from like the God's eye perspective, from like the cosmic eye, the cosmic level, it probably does look simple and silly.
Right. Have you read or watched Hitchhiker's Guide to the Galaxy?
Only the first 15 minutes.
Okay.
It got really morbid for me, and I was like, I don't know if I can watch this. All of humanity's gone extinct like that? Jesus.
It's really good. But it kind of plays along with that question. So I don't want to ruin it, but you should watch it. It's good.
Question even makes sense. At Aegisalt asks, what happens when you travel faster than the speed of light? You can't. You can't travel faster than the speed of light. I'm sorry, you just can't. You see, as you get faster and faster, as you approach the speed of light, you have more energy. And in relativity, energy takes more work to accelerate. So you end up requiring an infinite amount of energy in order to travel faster than the speed of light. And so it's just forbidden.
Unless they find something that's
they're in the
infinitely energetic.
They press the button or press the lever and they go faster than the speed of light. I don't care, because when I'm watching a movie, I'm not grading homework here, folks. I just want to sit back and relax and enjoy the show.
I'm convinced that this is just a limitation of our perspective of things, and that something out there, like the tachyon particles, something out there probably does go faster than the speed of light. We just can't see it or register it because it's beyond our scope of understanding of things. There's this whole series by the History Channel called The Universe, and I watched like all 6 seasons of it religiously. And the tachyon particle was the one that intrigued me the most. You spend the whole episode watching this guy try to figure out if it exists or not, only to find out he didn't find shit, because it's like we don't have the instruments to discover it. The notion of what a tachyon particle is, it cannot go slower than the speed of light. It has varying speeds, but only faster than the speed of light, which is crazy to think about if it actually does indeed exist.
I don't know too much about this particle, but
it's all theoretical.
There's so many theoretical things in the universe. It's definitely fun to think about. I'm gonna have to look into that because I don't know what that is.
It's theoretical in the sense of there's nothing to suggest that it actually exists yet.
Yeah.
It's more of it's truly just theoretical in that sense of the word of I came up with this theory.
Yeah.
As opposed to the theory of evolution, which is more harder.
Yeah.
You to dispute, right?
If the universe is made up of mostly space and it's expanding, what's at the edge? More space? The source wall? Something beyond human comprehension? At the edge of the observable universe is just more universe. The universe is larger than what we can observe because light can only go so fast and the universe is only so old. However, we don't know how big the universe really is. It could be infinitely big, or it could just be very, very, very large. But no matter what, the universe doesn't have an edge. It's not expanding into anything. It has no center. It has no edge. I know it doesn't make any sense, but since when has science ever made any sense?
Even if it does expand into something else, we wouldn't feel it or know it. I was watching a video talking about when Andromeda and the Milky Way collide. And more than likely, we're just gonna see more stars in the sky. Because they are set to collide, not in our lifetime, unless we figure out how to get past not tachyon particles, the telomeres. So the reason why we get old and die is because our telomeres at the ends of our cells shrink. And so scientists are trying to figure out how to elongate our telomeres again so that we can look as youthful as we do right now forever. And so if we can get past that, we can see the Andromeda and Milky Way eventually merge into one, but Earth will be fine. If our universe was to merge with another universe, there's so much space that we probably wouldn't even feel anything or notice anything other than, oh, there's more stars.
If you time traveled exactly 30 years into the future, you would not be where you started, but in space. Yes? Yes. At equal opposite.
I didn't even
Astrophysics question, is the quantity of dark matter in the universe increasing, decreasing, or has it remained the same since
We don't know.
equals 0?
We don't know.
Yeah, the amount of stuff in the universe, normal matter, dark matter, boring matter, whatever it is, has been the same. The density is dropping though because we live in an expanding universe. Every day our universe gets bigger and bigger, and so it's diluting out all that same amount of matter.
We can't know that for sure though, right? Because we can't, it's invisible matter. We're making a very, very strong assumption that it's the same. Matter cannot be created nor destroyed, only transferred is the idea. That's about the matter we understand. We don't understand dark matter, we just infer its existence.
I don't even understand what they're talking about. My brain is already starting to fail me.
If the Earth's axis wasn't tilted, would there be any way to directly observe the passage of a year? Yeah, good point here, because it's through the axis of the rotation of the Earth that we get our seasons and the transitions of the seasons. But even if we didn't have that tilt, we would still be able to notice the passage of a year because of the stars that we would see. As we go around the sun in our solar system, we see different sets of stars.
The axis is always
on
changing
our night
anyway.
Sky, and it rotates continuously
it
through the year. So anyone who can observe the night sky night after night over the course of a year would be able to figure out that we do have a year. At Thin Lins, if you have a car that travels faster than the speed of light,
the lights are
what happens
behind
when
you.
You turn on the headlights. First, you can't travel faster than light, but no matter how fast you're going, the light always comes out of your headlights at the speed of light, because that's what light does.
Wouldn't the lights be behind you? If you were moving at the speed of light, wouldn't the lights be in your rear view mirror because you're moving so fast? If you're
the light is still traveling though the speed of light, so it's still in front of you.
Okay, I heard something stupid a long time ago.
I want to know this.
No, I heard something dumb a long time ago. Like if you're in a car that could move at the speed of light, your lights can't project in front of you anymore because you're moving at the speed of light. So your lights would essentially be behind you now. I don't know. As I say it out loud, I feel stupid. So I'm just gonna shut up and keep moving along.
Is the structure of the universe as it stands at its current level of expansion related to the original singularity that resulted in the Big Bang? Not quite. At the very largest scales, we see something called the cosmic web. It's the very largest pattern found in nature. It's literally made of galaxies. But the cosmic web had its origins, but in the earliest moments of the Big Bang, where quantum fluctuations in space-time itself led to tiny little density differences, and then over the course of billions of years, these density differences grew up to become clusters of galaxies in the great cosmic voids. At PW Brewer, question for astrophysicists, that's me. How far from Earth could you detect a Hiroshima-sized atomic blast with our technology?
Wow, great question.
We'd probably spot it on the other side of the solar system, but that's it.
That's a great question.
Yeah, that is a really interesting
Whenever
question.
I read about science, I find I'm woefully out of depth. How can quasars produce radio waves, and why can't I listen to them?
Oh,
radio
wow.
waves come from, you take charged particles and you wiggle them around and it generates radio waves. So quasars are spewing out charged particles, they make radio waves. And you can listen to them. We detect quasars with radio telescopes and radio antenna. So you can. You're just tuning into the wrong station. You need a Quasar FM.
It's funny he says that because if my understanding is correct, the way we discovered the background microwave radiation in space that basically tells us about the Big Bang, it was by accident. It was like scientists had been looking for this for a very long time, and these two cable guys found it by accident in trying to set up a satellite, and they kept getting this interference, and they didn't know what the hell it was, and it was the background microwave radiation.
I didn't know that that's how it was discovered.
It was something like that. Now, I might be like messing up the actual details of the story, but it was something like that. Like, it was discovered on accident by two people who were not scientists. People in the science community were a little frustrated because they were like, we've been looking for this, and these two guys just found it. And so they're permanently part of history when they never meant to be.
That's awesome. That's actually how a few things get discovered accidentally. One of the forms of light, I think it might have been infrared, was discovered accidentally.
Oh, really?
Yeah, when he was trying to look at the visible spectrum, right? He had some sort of device that was then identifying something outside of the spectrum of visible light, and that was infrared, and that was heat.
Oh, wow.
At Artem Zinn, astrophysics question, into the void. Should it be possible to blow up a black hole from the inside? What? No, but they naturally dissolve through Hawking radiation. You just need to wait like 10 to 100 years. And that's not 10 to 100, that's 10 to the 100th power years. So be patient.
Yeah.
Thank you for all these amazing questions. I hope you learned something about astrophysics. I hope I was able to help. And I hope you had as much fun as I did.
This guy's a great spokesperson for astrophysics because
He's incredible.
I really enjoyed listening to him talk. And I thought that the way the video was put together was pretty cool by Wired. I thought the music they chose for the question when he was reading out the question was a fun little song. This is already a long video, so I'll wrap it up on this thought. I was talking about how the exoplanets we are finding are next to dwarf stars, right? Now, my understanding of this might be old or limited or just skewed because I saw it in a video. I haven't read up on this stuff. My understanding was we're looking out into the far reaches of the galaxy, right? And so in order to discover exoplanets, the easiest stars to observe are dwarf stars because the gravity's smaller, and so everything's closer to the dwarf star than it would be like on a star like ours, where everything's much further away. The easiest way for me to phrase it is like you have the silhouette of these planets passing in front of the star.
Yeah, it's a transient. I can't think of the actual term.
And so we can observe that, and from there somehow we determine like the size and the distance it has from the star. I don't understand any of this stuff. All I got from that was, okay, so dwarf stars are the easiest places to find exoplanets. That was it.
It might be the easiest. I know that there has to be exoplanets that we've found around
bigger stars?
Other stars. Yeah, not just dwarf stars, because like they said, the binary star systems have a lot of stars, have a lot of exoplanets as well. I've never heard of the dwarf planet thing, so I'm not sure. Dwarf star thing. So I'm not exactly sure.
Yeah, but anyway, that's what I heard a long time ago. Maybe I need to get updated on that. That was my understanding, just because everything's so far away. It's just easier to read something passing in front, like I said, like a silhouette or a shadow. It's easier to see that because it's closer to its star than like if someone was really, really far away from like absurd distances from Earth. It's harder to see Earth passing in front of the sun because we're further away from it or something like that. I don't know if I'm making any sense at all. So I always, it's like, as soon as I say this stuff out loud, I'm like, dude, am I saying something absurd and stupid? Someone in the comments will correct us that knows way more than I do. So you can come back to me and tell me later on if I'm completely off my rocker on that one.
Yeah.
But anyway, I enjoyed the shit out of this video. Hopefully you guys did too. And follow Amber on the social media, please. She's on Instagram talking about this stuff all the time.
Yeah, I love it.
And subscribe if you haven't already. Hit that bell icon, all notifications, and vote this up to let YouTube know you enjoyed what you watched. I'm Jaby Koay. This is
Amber.
Peace out.